Today's lesson is on how do we solve quadratics. Solve the following quadratic. 3x plus 2 times x minus 4 equals 0. Take a second to copy down the question. When I'm solving a quadratic, it has to be set equal to 0. Since this is already set equal to 0, there's nothing left. I do not have to do that step. I also notice that this quadratic is already in factored form. I have my first factor times my second factor. So I can already apply my zero product property. I could have 3x plus 2 equal to 0, or I can x minus 4 equal to 0. Now I just solve each one separately. Subtract 2 from each side. 3x equals negative 2. Divide both sides by 3. And I have x equals negative 2/3. For my other equation, I can add 4 to both sides, and I have x equals 4. So these would be my two solutions, x equals negative 2/3 or x equals 4. Solve the following quadratic. X squared plus minus 11x plus 19 equals negative 5. Take a second to copy down the question. When we're solving quadratics, we need to make sure that our equation is equal to 0. This quadratic is not equal to 0, so in order to make it equal to 0, I need to add 5 to both sides. When I add 5 to the left, I need to add it to the like term, which is the 19. So the x squared comes down, minus 11x comes down, and 19 plus 5 is 24, equals negative 5 plus 5 is 0. Now, since my quadratic is set equal to 0, I need to factor my quadratic. So I'm going to use my AC method, so I'm going to multiply the first term and the last term. That gives me 24x squared. The numbers that multiply to give me 24x squared and combine to give me negative 11x, which is this middle term, is negative 8x minus 3x. So I rewrite it as x squared minus 8x minus 3x plus 24 equals 0. Now I can factor by grouping. Group my first two and my last two terms. The GCF of my first two terms is x. So I can divide both sides by x, and I get x minus 8. The GCF of my next two terms is going to be negative, since my first term is negative, so it would be negative 3. So I can divide both terms by negative 3. When I do that, I get x minus 8 still equal to 0. Now, since my parentheses match, I can rewrite it as x minus 3 times x minus 8 equals to 0. Now I can apply my zero product property and set my first term, x minus 3 equal to 0, or set my second term, x minus 8 equal to 0. Now I can just solve each one separately. Add 3 to both sides, x equals 3. For this equation, I can add 8 to both sides, and I get x equals 8. So these would be my two equations, x equals 3 or x equals 8. Those would be my two solutions. And the last problem, solve the following quadratic. 7x squared plus 32 equals 7 minus 40x. Take a second to copy down the question. when I am solving this, I need to get my quadratic set equal to 0. This is not equal to 0, but I want to keep the x squared where it is. So I'm going to move this 7 to the other side by subtracting 7 from both sides. I'm left with 7x squared plus 25 equals negative 40x. Now, still not set equal to 0, so I'm going to add 40x to both sides. There are no like terms to that 40x on the left-hand side, but I'm going to write it in standard form from my highest exponent, which is a squared, to my lowest exponent. So the next one comes as 40x, and then plus 25 equals to 0. Now that it is set equal to 0, I'm going to factor. So to factor, I can multiply my first term and my last term. 7 times 25 is equal to 175 x squared. Now I need two numbers that multiply to give me 175 and combine to give me 40x. The numbers that work for that are 35x and 5x. So I have 7x squared plus 35x plus 5x plus 25 equals 0. I can group my first two and my last two terms. The GCF of my first two terms is 7x, so I can divide each term by 7x, and I'm left with x plus 5 in my parentheses. And the GCF of my last two terms would be a positive 5. So I can divide both terms by 5, and I'm left with x plus 5, still equal to 0. So now my parentheses still match, so I can rewrite my expression, my quadratic, as 7x plus 5 times x plus 5. Now I can apply my zero product property. 7x plus 5 equals 0, or x plus 5 equals 0. Now I solve each one separately. Subtract 5 from each side, and I'm left with 7x equals negative 5. Divide by 7, and I'm left with x equals negative 5 over 7. For my other equation, I can subtract 5 from each side, and I'm left with x equals negative 5. So these would be my two solutions, x equals negative 5 over 7, or x equals negative 5.